Chapter 6 and 7. We probably didn't have class, only one kid will. So I'm posting this video of me going over the important stuff from chapter 6 and 7. You can watch the whole video and I'll put some practice stuff up. But so chapter 6. Mathematicians do not want to see any negative exponents or zero exponents in a fully simplified expression. So all bases with negative exponents must be in their positive form, and bases with zero exponents must simplify out to 1. Okay? For example, t to the negative first. We learned and discovered that that is its positive form, and what a negative exponent means is 1 over t to the positive fourth. A negative exponent means 1 over the positive version form. Okay? Great. And now we're simplified. We go to d. D gets a little trickier. We have a negative exponent, and we have an exponent in the bottom. Right? It's 2 approaches. Because the bases are the same, we can keep the base the same and subtract the numerator exponent by the denominator exponent. So we get x to the negative 8th. So when we divide by the same base, we're allowed to subtract the exponents. But this is not simplified, so you get 1 over x to the 8th. So again, if you're dividing by the same base, we learned that we subtract the exponents. And then you can't have a negative exponent in your final answer, so 1 over x to the 8th. Okay, then we started looking for shortcuts to simplify expressions, and what we found is that negative exponents have a lot to do with fractions. Okay? And so it's a kind of shortcut to get a simplified answer. What you do is you look for what exponents each thing has, and they shift. So 2 is to the power of 1. It stays in the numerator where it's located. X to the negative third is not okay. So we're going to shift that down as x to the third in the denominator. That's where its positive form would end up. Okay, and you look at y to the negative second. It's in the numerator but has a negative exponent. We're going to drop it into the denominator as y to the second. Z to the fourth is in the denominator. There's no need to move it because it has a positive exponent. And here is our fully simplified answer: 2 x to the third, y squared, z to the fourth. Noticing that the x to the negative third and y to the negative 2 flip to the denominator in their positive form. Okay? All right. Here, sometimes you're going to have numbers in front. 2a to the negative fourth divided by 5b to the negative ninth. Just to remind you, 2 has a positive exponent 1. 5 has a positive exponent of 1. So 2 is going to stay in the top. 5 is going to stay in the denominator. A to the negative 4, though, that can't stay up there. It's got to drop down to its positive form in the denominator. And b to the negative ninth, which is in the denominator, needs to shift up as b to the ninth in the numerator, like so. Now we are fully simplified. Okay. I bring up this next one. We have negative 2y to the 7th over 14y to the 5th. Okay? Remember, this is division. And when you have coefficients or numbers in front, that's like its own sort of separate, remembering about division. And then I'll kind of separate it like so. Negative 2 over 14 can be simplified to negative 1 over 7, because this is just a fraction, right? And then y to the 7th divided by y to the 5th, well, you subtract the exponents, so 7 minus 5 is 2. So we have negative 1/7 times y to the 2nd. And we're not going to see one like this exactly on the quiz, but I just wanted to remind you what we did with exponents. All right, so this is more like the one you're going to see. You're going to read it first. 3, m to the 5th, k to the negative 6th, 12, k to the negative 2nd, n to the negative 3rd. Negative 7th, sorry. All right, I'm going to first play the shortcut game. 3 stays where it is. M to the 5th is good. K to the negative 6 needs to shift to the denominator. 12 is okay where it is. K to the negative 2 is not okay. K squared. N to the negative 7th needs to move up as n to the 7th. Okay. But we do have some more simplification. We have this and this. 3 divided by 12, we can write that as 1/4 m to the 5th. On the here, we got 2 minus 6, so that 2 minus 6 is -4 n to the 7th. But 2 minus 6 is -4, but we can't have this up here. So we got to shift it down, drop it like so. Now we are fully simplified. M to the 5th, n to the 7th, 4k to the 4th. Okay. I'm doing some more to practice. You can always pause me if you want to give some tries. I'll show you some shortcuts here as well. All right. We're told to simplify this. We got a lot of stuff up here. There's nothing to switch, so what I'm going to do is look for anything with the same base and numerator and denominator. Okay. I have r to the 7 and r to the 3rd. I subtract 7 minus 3 is 4. S to the 7th, S to the 3rd. That's 7 minus 3 is 4. T to the 2nd over T to the 2nd is T to the 0. But T to the 0 is just 1. So now we're simplified. Okay. Here. This is more like the one you're going to see is on the final. Here, we'll handle this first. 32 divided by -8 is -4 over 1. X to the 3rd over x. You have 3 x's multiplied together on top, 1, so we're left with x squared on top. 2 minus 1, we have y to the 1st on top. Z to the 5th divided by z to the 2nd. Again, you subtract the exponents when the bases are the same. And there we have it. Okay. Again, more like what's going to be on the final. You look at it. I see 15 divided by 5, so I know that is 3 over 1 right away. I have x to the 6th and x to the 1st, so if I subtract the exponents, you still have 5 x's in the numerator multiplied together. Here, you might want to do the math. It's y to the -9th minus -11. So we add the exponents, so this gets y to the 2nd in the numerator. You could also shift that up as y to the 11th on top and y to the 9th on bottom. Right? You could shift these two, and then you can still see you have 11 y's on top, 9 y's in the bottom. You're left with y squared at the top. Pause me. Try this one. I'm going to show the answer. Pause me now. MCAS goes until forever. Unless they cancel it early and send you to class. I don't know. Okay. There's one more for you to try. Pause me. Take a look. See if you can do it yourself first. Alright, I'm going to do it. 8 divided by 4 is 2 over 1. C to the 3rd is cool where it is. C to the 1st, actually, I'm going to shift up. D to the 2nd would be cool where it is. F to the 4th is. D to the 2nd in the denominator is good. F to the -3rd would shift up as F to the 3rd. So there's that game of shifting, right? And I gotta look, can I simplify more? Yes, I have C to the 3rd, C to the 1st. So I have 2 C to the 4th. The D's cancel because anything divided by itself is 1. And then you're left with F to the 7th. This is a perfect example of what we're going to see on the final. All right, more of Chapter 6. We're going to test you on simplifying expressions by adding like terms. So pause me. Try to simplify it yourself. I'm just going to keep going. You're going to have to distribute the negative first. Okay, so you get 3 plus 5x squared minus 4x. Distribute the negative. All the signs are going to flip. So we get negative x squared minus 6 minus 5x. Okay? And you got to find like terms and do the math. 3 minus 6, negative 3. Any like terms to positive 5x squared? Well, sure, negative 4x squared, a negative x squared. So 5x squared minus x squared, positive 4x squared. The last one, you have negative 4x and negative 5, so that's negative 9x. Okay, you will have to do one like this on the final. All right, hey, pause me again. Give this one a try. Now that you saw me do this one, see if you can do it on your own. Spoiler in 3, 2, 1. Again, you're going to have to distribute the negative first. There's no negative up here, so I'm just going to write down what I have left, what's already there. 2b squared becomes negative 2b squared. Positive 8c becomes negative 8c. Minus 6 becomes plus 6. Okay, then you look for like terms. Boom, 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 boom. Okay, 4b squared minus 2b squared is 2b squared. 3c plus negative 8c is negative 5c. Negative 5 plus 6, positive 1. There we go. All right, some more chapter 6 stuff. I'm only going to focus on what? You're going to have to multiply x plus 5 times x plus 2 on the final. You can do distributive, but again, I like to always go with the area model if I'm asked to multiply this. X and 2, x and 5, you get x squared, 2x, 5x. 2 times 5 is 10. So it's x squared plus 5x plus 2x plus 10. And we simplify down to x squared plus 7x plus 10. And this is some of our newer stuff, so it should look more familiar, not as hard to bring up. All right, and again, you're going to have one more like this on the final. So 4x minus 5 times 7x plus 5. Again, I go to the area model. You pause me. Okay. Put one parentheses on the top, one parentheses on the side. Make sure that's a negative 5. Okay. And then find all the products. 4x times 7x is 28x squared. Don't forget the x times x is x squared. 5 times 4x is 20x. Negative 5 times 7x, negative 35x. Negative 5 times 5, negative 25. So we have 28x squared plus 20x minus 35x minus 25. Like terms in the middle, 28x squared minus 15x plus 25. There's your answer. Okay. All right, and of course, one of our last topics is factoring. Okay, you're going to be asked to factor 3 times. Let me double check. Yeah, 3 times. Okay, so I want to hit up the ones you're going to do. One of them is going to give you 3 terms and ask you to factor it. First step, notice that it's 1, 2, 3 terms. Second step, look for a GCF other than 1. Does 10x squared minus 7xy plus 10y have a GCF other than 1? The answer is yes. You can factor out a 2. Okay. Then we're left with 5x squared minus 3xy plus 5y. Okay. And then you look at what's left to see if we factored more. This is not in any form that we know how to do. So that's it, as far as you can go. And you're going to have to do that on a test. You're just going to do step 2 of our factoring guide. Pull out a GCF, write down what's left. Okay. We're going to factor this. If you want to pause me or just keep watching, there's 1, 2, 3 terms. There's no GCF other than 1. It's in the form x squared plus bx plus c. So I know that I need to find things that multiply to negative 10 that also sum to the negative 3x. And that would be some sort of 5 and 2 combination. Negative 5 and 2. Okay, and because it's x squared, we can go right to our shortcut like so. All right, and again, we're reversing distributive property. So here, pause me. Give this one a try. Spoiler in 3, 2, 1. Again, it's in the form x squared plus bx plus c with no GCF. So multiplies to negative 55 and sums to negative 6. 11 and 5 pop in my mind, and I think if I get a combination, boom. Okay. Because it's an x squared and I found the two numbers, I don't have to write as 4 terms. I can go right to the shortcut. Okay. X minus 11 times x plus 5. There's one like that on the final. All right, and the last review from Chapter 7. You're going to be asked to completely factor something, okay, all? That means you have to do step 2 and then step 3. So, in step 2, you look for GCF other than 1. Does x to the 4th, 2x to the 3rd, and 5x squared have a GCF other than 1? The answer is yes. They all have at least an x squared. So I'm going to pull out the x squared from all of these. So I'm left with x squared plus 2x minus 15. Now, step 3 says to look at what's left. Can it be factored more? Well, yes, this is in the form we just saw up here. So check to see if something multiplies to negative 15 and sums to 2. Like 5 and 3. So 5 and negative 3 add up to 2. So that means x squared plus 2x minus 15 came from two parentheses that looked like x plus 5 times x minus 3. And we pulled out an x squared earlier. And there you have it. Okay, I know that was quick, but I just hit all the topics you need to be ready for from Chapter 6 and 7. Making sure that you double check other, Chapter 5 and Chapter 4. Go back and look at other stuff, okay? But know that you worked really hard during a pandemic, and I know it was hard to focus, and it was easy to get the easy way out and find the answers online. But again, I can't stop you. I'd like you to do as best as you can on your own. One test grade is not going to determine whether you pass or fail Algebra 1, okay? I think that's it for notes. You have some chance to do some classwork as well. I'll post that along with this video.